Hello everyone, in this video we're going to look at creating custom exception classes. So we're going to demonstrate how we can create our own exception classes for use in our programs. Now why would we want to do that? Well, it allows us to have fine-grained control of error handling. Suppose we have some program that needs to deal with a very specific type of error. Now the Java SDK comes with a whole bunch of exception classes predefined, but maybe we can't express our error in a meaningful way using those. Well, the easy way around this is just to write our own exception class that can be meaningful for a particular type of error. So that's what this video is going to look at, and let's get started. In Eclipse, I've created a new project called Custom Exceptions, and we're going to add a new class to this, and we're going to call it Invalid Radius Exception. Now, in Java, when we're creating exception classes, they should all extend from the base class, which is called exception. So, extends exception. Alright, so this exception class is going to be only dealing with an invalid radius. So, we're creating a circle and passing in a value for the radius that isn't valid, for example, a negative number. So what we're going to do here is store a private double for the radius that caused the error. Next we need a constructor. So public invalid radius exception. And this is going to take in a radius parameter. So double radius. Now what we're going to do here is call the superclasses constructor. So we use the super keyword. Now, exceptions constructor can take a string as a message. Now, this message gets used in your program if you want to print out exactly what happened. So we're going to create a meaningful message here. Invalid radius. And then we concatenate that with radius. Finally, we'll set this.radius to the parameter radius. Okay. And then finally, we'll just have a quick method to get the radius. And that's our exception class done. So it's a very small class, and exception classes are very simple to write. So why don't we now put this to use to see how it works? So we'll create a new class here, and I will call this one circle with radius exception. Alright, now this is going to be a circle class, and it's going to be similar to some code we've written in previous videos. So I'll try and get through the boring bits kind of quickly. So private double radius, private static int number of objects equals 0. Okay, so a default constructor, public circle with radius exception. We'll call the other constructor with a value of 1.0. Now we better write this other constructor. Alright. Now, what we're going to do here is we need to assign this new radius to the class's radius variable. So we want to check to make sure the radius that they enter, the radius that gets passed into the constructor is valid. So what we're going to do is create a set radius method. So public void set radius double new radius. Okay, and in here we're going to have a check, and if the radius is invalid, then we're going to throw an exception. Now this means we need to modify the method signature to say that this method might throw an exception. So the way we do that in Java is with the throws keyword, and then the type of exception that it's going to throw. So invalid radius exception. Alright, so now we know that this method might throw an invalid radius exception. So the way we do this is if new radius, the one that was passed as a parameter, is greater than or equal to 0, then there's no problems. we can just set the radius equal to new radius. Otherwise, if the radius is negative, then we do have a problem. And what we're going to do is throw a new invalid radius exception. And we'll pass in new radius as a parameter. Okay, so this is really important. And now we can use this method inside our constructor. So we're going to try to set the radius. And we'll also increment the number of objects. Finally, we'll have a catch to catch the exception. Invalid radius exception EX. And what we're going to do in here is just print the stack trace for the exception so we can see what's happening. So EX.print stack trace. Okay, so just quickly, that's the main part of our class written. What we're going to do now is just finish it off. So we need a getRadius method. So there's that. And we'll have a findArea, which returns radius multiplied by radius multiplied by math.pi. Okay, and with that, that's the basic circle class written. So let's try and run this and see what happens. Actually, we can't run this. We need a main method. What I'll do is just create another class, and we'll call this radius exception test. Alright, so we need a main method. And in here we're going to create a couple of circle objects. So circle with radius exception C1 equals new circle with radius exception default constructor here. And what we're going to do is just print out the area. System.out.println area of C1 is C1.findArea. Okay, so I'm just going to copy and paste this code 2 more times. So we'll make this C2. The area of C2 is blah. Now what we're going to do here is use the other constructor which takes a value. So let's put in 120 here. And then for the third one, we'll call this C3. What we'll do is pass in an invalid radius. So I don't know, minus 50. 59 in fact. So with that, we can test out how this exception is going to work. So let's run this now. Run as Java application. And we can see here that C1, the radius is 1, so the area is pi. C2, the area is 45,238. And the area of C3 is 0 because we never had a radius assigned, because we get this stack trace. And I'll just maybe make this bigger so we can see it. So the stack trace prints out the call stack of where the error occurred. So you can see here, it started in radius exception test main on line 11. So if I had line numbers turned on, this would be line 11. But it goes further. Okay, it happened inside the constructor on radius exception line 14, which I'm betting was where is it? This one, this line here. And then we have our message from our invalid radius exception. So that's where this message comes in. It's really useful as part of the stack trace. So what we did here was we printed this stack trace. Normally what we might do is print out a nicer error message, but I really wanted to demonstrate how this actually works. So with that, that's pretty much it for this video. So just to summarize, custom exception classes, when we're writing them, should extend from exception or one of its subclasses. So exception has some subclasses that might make sense for us to extend. And the reason we do this is because it allows us to write code for handling a very specific error. We can have custom error types depending on what we're trying to do. So that's it for this video. Thanks a lot.